Hello viewers, in today's class we are going to solve one important definite integral, and here we have this integral that is from 0 to 1 square root of 3 minus 2x minus x square, right? So here we are going to solve this integral by making use of trigonometric substitution, right? So let us start. Now here if we see that this integral is of the form square root of ax square plus bx plus c dx, right? So this integral is of this type, and here we have a quadratic polynomial inside this square root sign, right? So what we will do in such problems, let us first denote this integral by the letter I, and usually what we do, we try to convert this quadratic polynomial into a perfect square, right? So what we will do, we'll write it like this: 0 to 1 square root of c. Here we have the coefficient of x square as minus 1, and here the coefficient of x is negative 2. So what we will do, let us take negative sign outside the this bracket. So we have x square plus 2x and minus 3, right? So we can write this expression like this by taking negative sign outside this expression, right? So here we have dx. Now what we will do, we'll take this quadratic expression, that is x square plus 2x plus minus 3, and we can see here we have x square plus 2x, right? So this can be written as x plus 1 whole square. So we'll have x square, then we have the 2ab term, that is x square plus 2x, and then we have 1 square, that is 1, right? So we'll eliminate it by writing negative 1 here, and here we have negative 3, right? So we have x plus 1 square whole square, and here we have minus 4, right? So now we can write this integral as 0 to 1 square root of here we have the negative sign, and then we have x plus 1 square minus 4, right? Okay, now we can multiply these two terms by this negative sign. So we are left with 0 to 1, then we have square root of 4 minus x plus 1 square whole square, right? So now this integral is converted into this integral, right? And here we see that we can also write this 4 as 2 square minus x plus 1 whole square, right? Okay, now here in order to proceed further, we'll make use of the trigonometric substitution. So here we can make a proper substitution here. So we can take x plus 1 is equal to 2 sine theta, right? So the appropriate substitution here is x plus 1 is equal to 2 sine theta. So now we can differentiate both sides with respect to theta. So we have dx over d theta. The derivative of 1 is 0, and here we have 2 cos theta. The derivative of sine theta is cosine theta. So now we can write dx is equal to 2 cos theta d theta, and see here x varies from 0 to 1, right? So we'll change the limits accordingly. So when x is equal to 0, we can find out the value of theta from this expression, right? So here we'll take x is equal to 0. So we have 0 plus 1 is equal to 2 sine theta, and we have 1 is equal to 2 sine theta, and sine theta is equal to half, and for theta is equal to pi over 6, we have sine theta is equal to half, right? So when x is equal to 0, theta is equal to pi over 6, right? Okay, now similarly when we have x is equal to 1, here we can substitute x is equal to 1 to find the value of theta. So we have 1 plus 1 is equal to 2 sine theta, and 1 plus 1 is equal to 2. So we have 2 is equal to 2 sine theta, and here sine theta is equal to 2 over 2, that is 1, and sine theta is equal to 1 implies that theta is equal to pi over 2, right? So when x is equal to 1, we have theta is equal to pi by 2, right? So now this integral can be now written in terms of theta. So we can write it as pi by 6 to pi by 2, and here we have square root of see, here we have 2 square minus x plus 1 square is 2 sine theta whole square. So we have here 2 square and sine square theta, and for dx we can write here 2 cos theta d theta, right? So here we can have 2 cos theta d theta, right? Okay, so now we have to simplify this expression. So we have the integral I as pi by 6 to pi by 2, and in the under the square root sign we have here we have 4 minus 4 sine square theta, and if we take 4 outside we have 1 minus sine square theta, and 1 minus sine square theta is cos square theta, right? So here we have 4 times cos square theta, and here we have 2 cos theta d theta, right? Okay, so now we can simplify it further. So we have pi by 6 to pi by 2, and here we have simply 2 cos theta, and this is 2 cos theta d theta, right? Okay, so now we can take 2 outside, and we have pi by 6 to pi by 2, and here we have 2 times cos square theta d theta, right? So now our integral reduces to this type of integral, right? Now here we'll make use of a trigonometric identity. So we know the formula for cos 2 theta. Cos 2 theta is equal to 2 cos square theta minus 1, right? So this is an important trigonometric identity. So 2 cos square theta can be written as 1 plus cosine 2 theta, right? So 2 cos square theta can be replaced by 1 plus cos 2 theta. So now the integral I becomes 2 times limits from pi by 6 to pi by 2, and here we have 1 plus cos 2 theta, right? And here we have d theta. Now we have here 2 terms. The integral of 1 d theta is simply theta, and the integral of cos 2 theta is plus sine 2 theta divided by 2, and the limits are from pi by 6 to pi by 2, right? Okay, now here we can substitute the limits and we'll take the difference. So we have 2, and first we will take pi by 2 here. So we have pi by 2 plus sine. Here when we take pi by 2, so we have 2 times pi over 2, 2 and 2 get cancelled, so we are left with simply pi sine pi over 2, and when we take here theta is equal to pi by 6, we have here pi by 6, and then here we have sine 2 theta, so 2 times pi over 6 is 2 3s are 6, so we have pi over 3. So here we have sine pi over 3 divided by 2, right? So now we have a very simple expression here. We can simplify it. So we have pi by 2 the value of sine pi is equal to 0. So this term disappears here. So we have 0, and then here we have pi over 6, and this is sine pi over 3, that is sine 60 degrees. So this is root 3 over 2 divided by 2, right? Now we can simplify it. So we have I is equal to 2 times, and here we have pi over 2, and here we have minus pi over 6, then we have minus square root of 3 divided by 4, right? Okay, now multiply these three terms by 2, so 2 get cancelled here, so we have pi minus, here we have pi over 3, and here we have square root of 3 over 2, right? Okay, now we can simplify these two terms. So we have 3 pi minus pi, that is 2 pi over 3, and here we have minus root 3 over 2, right? So the value of this integral can be taken as 2 pi over 3 minus square root of 3 over 2, and this expression can also be written by taking the LCM of 3 and 2, that is 6, and here we have 3 2s are 6, so 2 2s are 4, so we have 4 pi minus, here we have 2 3s are 6, and we have 3 times square root of 3, right? So we can also accept this expression as the final answer for this definite integral, right?